Good morning, Algebra 2 students. This video is going to start out with a review on statistics. So we've talked about mean, median, mode as being our averages. So in this case, to find the mean of this set of data, we're going to add up all of these numbers. And if I do that, I would get a total sum of 93. And I'm going to divide by how many numbers I have, which in this case is 9. And my mean would be 10.3 repeating. My mode is the one that occurs most often, and in this case you can see that the 8 is the only one that occurs more than once, so my mode would be 8. The median, there are 9 numbers here, so there is an exact middle, and that median would be 9. There's 4 numbers less than that and 4 greater. And the range is simply the highest minus the lowest. 18 take away 3, which is 15. The first quartile then is the median of the numbers less than the median. There's even number there, so we're going to take the average of the 7 and the 8, which is 7.5. And that would be my first quartile. My third or upper quartile is the quartile of these 4. The median of these 4. The middle is between 14 and 15, so my third quartile would be 14.5. My IQR is simply the range of those two IQRs, so 14.5 minus 7.5, which would give me an IQR of 7. To determine outliers, I'm going to take 1.5 times that IQR. So 1.5 times 7 gives me 10.5. I am then going to subtract that from the first quartile, and I'm going to add it to the third quartile. By doing this, I get a small number, or the lower end number to be -3, and I get the top end number to be positive 25. That comes from these two values right there. So any numbers between -3 and 25 are considered to be normal. Therefore, in this case, there are none. There are no outliers in this set of data. To construct a box plot of this one, or box and whisker plot, I'm going to make a box that is going to go from my first quartile to my third, so from 7.5 to 14.5. I'm going to extend these boxes to my minimum, which is 3, and to my maximum, which is 18. And I'm going to label where the median is, which is at 9, which should be right there. And that is a box and whisker plot of this set of data. So hopefully this is a review, and this is going well for you. For the concept students, this is quite a bit of a review from some past lessons. And now we're going to talk about a couple different statistics. I know second hour has talked about this a little bit, but percentile rank. This is the percent of the data less than or equal to that number. So in this set of numbers, let's say these are scores on a test out of 75 points. If I'm going to be finding the percentile rank of a score of, let's say, 68, there are 4 numbers that are less than or equal to 68. That's 4 out of the 9 total numbers, which is 0.444 repeating. So this would be the 44.4 percentile. If I'm looking for the percentile rank of a score of 73, now I'm looking at all of these scores. I'm including both 73s because it's less than or equal to. There's 7 of those, 7 out of 9, which would be 0.777, which would be about, if I round to the 78th percentile. The percentile rank of 75 is all of these numbers. So that'd be 9 out of 9. So that would be at the 100th percentile. That means that you have scored the best. No one has scored any better than you on this particular test. Percentile rank of a score of 65. That would be these two. So it would be 2 out of 9, which is 0.2 repeating, or 22 percentile. Now we're going to talk about the standard deviation and variance. Standard deviation is a measure of how spread out the data is. And we're going to use what we call a 3-column method to do this. In the first column, we're simply going to list all the numbers vertically. And then I'm going to find the mean. So if I add up all these numbers, I get 36. If I divide by 6, my mean in this case is 6. My second column is going to be the deviation from the mean. So 4 is 2 less than the mean. That deviation would be -2. This 4 would be -2, 5 would be -1. 6 would be 0 because it is the mean. 7 would be a +1, and 10 would be a +4. And then my third column, I'm going to square all these, which makes them all positive. I'm going to add up this third column, which gives me 26. I am then going to divide by how many numbers I have. So 26 divided by 6 gives me a total of 4.3 repeating. This number is what we call the variance. And then to get the standard deviation, we're going to take the square root of that variance, the square root of 4.3 repeating, which would be 2.08. And that is the standard deviation of this set of data. Basically, it means that each of these scores is on the average about 2 units away from the mean. So now we're going to look at a different set of data. These are 6 numbers. I think you'd probably agree they're a little more spread out than the ones that we just did. These also have a mean of 6. So the average is 6. They have the same average. Why are these two sets different? Because one of them is more spread out than the other. So again, I would list them all in a vertical column. My deviation now of 1 would be -5, 2 would be -4, 7 is a +1, 8 would be 2, 9 would be 3, and 9 would also be 3. Next column, I'm going to square all those deviations. So 25, 16, 1, 4, 9, and 9. Going to add this column up. 41 and 5 is 46, and 18 is 64. I'm going to take 64 and divide by 6 because there are 6 numbers in the list. This is what we call the population variance, which would be 10.6 repeating. Again, that is your variance. And then your standard deviation would be the square root of 10.6, or the square root of that variance, which is about 3.27 would be the standard deviation. That's a higher number than the previous one, which means the data was more spread out. So I hope this helps you complete your assignment for today.